Alright, let's take a look at what you are supposed to do for Lab 3. So you have this function, and you are supposed to implement it 3 different ways. Once with a just any gates you want, and once with a decoder, and once with a multiplexer. Let me make sure that is correct. So any gates, multiplexer, and it tells us it's 74 LS151 and the decoder LS138. Let's see if I have the data sheets for those. There's 138 and we need LS151. So, let's start with making a truth table. Alright, so I have my variables R, S, T, and U. Oops, no, that's my min-term there. So the first column is my min-term, and then R, S, T, and U, and then my function is named storm, and it has a value of 1 for min-terms 0, 9, 1, 9, 11, 14, and 15. So okay. 0, 1, 9, 11, 14, and 15. And so, to make this function, it is the sum of those min-terms. So we could just say RST, that's min-term 0, plus RST, that's min-term 1, plus R, let's see, oh no, never mind, I'm sorry, we have the 4 variables. RSTU, RSTU, and min-term 9 is RSTU, and min-term 11 is RSTU, and min-term 14 is RSTU, and min-term 15 is RSTU. So I could also at this point make a Carnot map to simplify it, but looking at these min-terms, I can see how to simplify them algebraically pretty quickly. So the first 2 terms I can factor out an R bar, S bar, T bar, and left with U bar plus U. The next 2 min terms I can factor out an R, S bar U, and I'm left with the T bar plus T. And the last two I can factor out an RST, and I'm left with the U bar plus U. And this term right here, anything or its conjugate, that's not the right word. Anything plus its complement always equals 1, and then anything times 1 is just itself. So this is just R bar, S bar, T bar, plus R, S bar, U, plus RST. And then if we wanted to do that with a Carnot map, zero, 1, 9, 11, 14, 15. And then if we look at those terms, that is R bar, S bar, T bar, or R, S, T, or R, S bar, U, which is, of course, exactly what I got right there. So if I wanted to do that with just any gates available in the lab, I would have R, S, and T, and then I would, for each one of these, come up with its complement, and then I'd use a 3-input AND gate to make each of these terms. And then I would use a 3-input OR gate. Actually, I don't think you have a 3-input OR gate, so I'd use a 2-input OR gate to OR those together, and then OR that with another OR gate. And then that would be that circuit. And to map that to chips from the lab, you would have a and you can find out what chips you have available in the lab. Right here. So I already got the inverter. You also have a 74X11 is the triple 3-input AND gate. This one was the 74LS00. 74x11. And then we have 74x32. The X just means it could be any number of different things. These are LS. And then we can go back and look at this and label, well, if we look at our NOT gate, you have that's not a NOT gate. That's the OR gate. Oh no, that's a NAND gate, so that is not what we want. We want 74x00. Oh no, I'm looking at the wrong one. X04, 74x04. Okay, then if you look at your instructions for Lab 3, it shows you, nope, it's not in Lab 3. Where would it be? Okay, so that is the way that we want to label our circuit, and Okay, we have the pin number in parentheses. Okay. So the inverter has 6 different gates, and so I will just put these on gates 1, 2, and 3, and the input. So and then it's A is the input and Y is the output. And then the pins for 1 are 1 and 2. And for 2, they are 3 and 4. And for 3, they are 5 and 6. So there's our inverter. And then for our 3 input AND gate, it's 1A, 1B, and 1C with output 1Y. And A, B, and C, 1A, 1 C. So 1A is 1, 1B is 2, and 1C is 13. So 1, 2, 13. And 1Y. One Y is 12. Two A and 2B are 3 and 4. And 2C is 5. And 2Y is 6. 3A, 3B, and 3C are 9, 10, and 11. And 3Y is 8. And then for our OR gate, we have A, B, and Y are 1, 2, and 3. And then for 2, it's 4, 5, and 6. Okay, so that would be the circuit using basic gates, and then to map it like this. You have your ground going to each of those, so ground going to pin 7 on each of them, and VCC going to pin 14 on each of them. So let's see. And then 1Y is going to 1A. Two Y was 2Y is going to 1B and 2B, going to pins 2 and 14. Okay, I'm going to stop this, I think, and, oh no, there we go. Two Y was going to, so 2Y is going to 2 and 4. And 3Y was going to 13. And then the other inputs into the AND gate were let's see, so 1C, I got that. Alright, and then 2A is R, 2B is not S, so R is 2A pin 3, 2B I've got that, 2C is U, and gate 3 is R, S, and T. the outputs 1y and 2y go into 1a and b. And 3y goes into 2a. Good morning. I'm making a video. And 1y goes to 2b. And then this, I'm making a video. No, thank you. I'm making a video. Okay. And then this is our output storm right there. Okay, I'm going to stop this and upload it, and then I'll do the multiplexer and the decoder.